Since childhood, we have been told that drinking milk is the ultimate key to building strong bones. But behind this simple daily routine lies a complex chemical signal that profoundly alters your biology. For decades, this belief remained an unquestioned truth in homes worldwide. Yet, modern science reveals that every single sip triggers a cascade of reactions inside your digestive tract and blood. Every time you consume milk, your body receives a complex molecular message. This message directly communicates with your digestive organs, your bones, your skin, and even your master hormones. These biological reactions are not identical for everyone. How your system responds depends entirely on your genetics, your age, your current gut health, and your metabolic activity levels. Today, we will trace the complete physiological journey of milk. We will follow it from the moment it touches your tongue to the cumulative effects that build up over weeks and months. You will discover exactly how your stomach breaks it down, how your bloodstream absorbs its nutrients, and what specific chemical signals it sends directly to your cells. We will pinpoint the exact moment when these signals stop being beneficial and instead begin to trigger systemic issues, helping you decide if milk truly belongs in your daily diet. To understand this, we have structured our investigation into clear phases. First, we examine the immediate digestive reactions, followed by nutrient absorption and hormonal responses. Next, we will explore the medium-term cumulative effects on your organs. And finally, we will dive into the silent warning signs that indicate milk is causing harm to your system. By understanding the raw biochemistry of dairy, you can move past marketing myths and make highly informed, practical decisions for your long-term health and wellness. Imagine drinking a single glass of whole milk, about 250 milliliters. On the surface, it is a simple act, but your body immediately begins making complex decisions. The moment the cool liquid pools in your mouth, salivary enzymes begin to analyze its composition, preparing the rest of your digestive tract for the incoming nutrients. The milk then travels down your esophagus and enters the stomach. Here, it is instantly met by highly acidic gastric juices, which begin the work of breaking down its complex proteins. Milk contains two primary protein families, casein and whey. When casein proteins come into direct contact with your stomach acid, they undergo a fascinating structural transformation. The acid causes the casein to clump together, partially curdling the milk right inside your stomach. This clumping process is a natural, necessary step for proper protein digestion. These thick casein clumps take significantly longer to break down, which slows the rate of gastric emptying. This slow digestion has a highly beneficial side effect for hunger control. By remaining in your stomach for an extended period, casein helps you feel full and satisfied for hours, preventing sudden spikes in appetite and unwanted snacking. Whey protein, on the other hand, behaves entirely differently. It remains liquid and is rapidly absorbed by the system, quickly delivering amino acids directly to your muscles. These rapid-acting whey proteins are exceptionally rich in branched-chain amino acids, which are the primary building blocks your body uses to repair and rebuild muscle tissue. Meanwhile, lactose, the natural sugar found in milk, bypasses the stomach completely and moves directly into your small intestine, where it meets its first major biological hurdle. Embedded within the delicate lining of your small intestine is a vital enzyme called lactase. Its sole responsibility is to break down complex lactose molecules. Lactase cleaves lactose into two simpler sugars, glucose and galactose. Once split, these sugars are easily absorbed through the intestinal wall and into your blood. If your body produces an abundant supply of lactase, this process occurs seamlessly. Glucose enters your bloodstream smoothly, providing a steady, reliable source of energy. But if your body lacks sufficient lactase enzymes, the lactose remains completely unbroken. It continues its journey downward, entering the colon completely undigested. Once in the colon, the resident gut bacteria immediately begin to ferment this undigested sugar, using it as an abundant, rapid food source for their own survival. This rapid fermentation process releases hydrogen, methane, and carbon dioxide gases, which quickly build up inside your lower digestive tract, causing physical stretching. This gas accumulation leads to painful bloating, abdominal cramps, and, in many cases, severe diarrhea. This is the physiological reality of lactose intolerance. Contrary to popular belief, lactose intolerance is not an allergic immune reaction. It is simply a physical mismatch between the food you eat and the enzymes you produce. This enzyme deficiency is incredibly common. In fact, approximately 65% of the entire global population loses the ability to digest lactose after early childhood. Losing lactase production is actually the default genetic setting for humans. Historically, our ancestors only drank milk during infancy to survive and grow. The unique ability to digest lactose into adulthood is a relatively recent evolutionary adaptation. It first emerged in populations that domesticated dairy cattle. Over thousands of years, a specific genetic mutation spread rapidly through communities that relied heavily on dairying as a primary life-saving food source. This mutation, known as lactase persistence, allowed adults to continue producing the lactase enzyme throughout their entire lives without any digestive distress. Today, this genetic trait is highly concentrated in Northern Europe, where dairy farming has a deep, unbroken historical lineage spanning many generations. We also find high pockets of lactase persistence in pastoralist communities in Africa and parts of the Middle East, where livestock herding remains a core way of life. If you belong to the genetic group that digests lactose easily, the nutrients from your daily glass of milk pass smoothly through your gut barrier and enter your blood. Once in your bloodstream, these essential nutrients, including calcium, proteins, healthy fats, and vitamins, begin sending highly specific signals to your tissues. Calcium is the mineral most famously associated with dairy. A single glass of milk delivers roughly 300 milligrams of highly bioavailable calcium. This amount represents nearly 1/3 of the total daily calcium requirement for an average adult, making milk an incredibly dense source of this essential mineral. However, calcium cannot perform its duties alone. For your body to actually absorb and utilize this calcium, it requires the vital assistance of vitamin D. Without adequate vitamin D, calcium simply circulates aimlessly in your blood, unable to penetrate your bones where it is desperately needed to maintain strength. This is precisely why commercial milk is almost universally fortified with vitamin D. It ensures the entire biological absorption chain works flawlessly, from start to finish. When calcium successfully reaches your bone tissue, it activates specialized cells called osteoblasts, which act as the dedicated bricklayers of your skeleton. These diligent cells pull calcium and phosphorus from your blood, integrating them into the bone matrix to continuously increase skeletal density and overall strength. This mineralization process is highly critical during childhood and adolescence, when the skeleton is growing rapidly and demands a constant supply of raw materials. It is equally vital for postmenopausal women, who face a natural decline in estrogen levels that can accelerate bone loss and lead to skeletal fragility. But here is a crucial truth that is rarely discussed. Simply consuming calcium is not enough to guarantee strong bones. Your bones must receive a physical stimulus. The most powerful stimulus for bone remodeling is mechanical load activities, like lifting weights, running, walking, and resisting gravity through physical movement. If you lead a sedentary life, your body sees no biological reason to store calcium. The extra mineral simply remains in your blood, eventually being excreted. Calcium is merely one piece of a much larger physiological puzzle. The system that utilizes it depends heavily on your daily movement and lifestyle habits. Now, let us focus on protein. A single glass of milk delivers 8 grams of complete protein, meaning it contains all 9 essential amino acids. Essential amino acids are compounds your body cannot manufacture on its own. They must be obtained directly through your daily dietary choices. Once absorbed, these amino acids flood your bloodstream. When they reach your skeletal muscles, they activate a master genetic pathway known as mTOR. The mTOR pathway acts as your body's primary construction alarm. It signals to your muscle cells that ample building materials are available to repair and grow. Because milk combines fast-digesting whey and slow-digesting casein, it provides your muscles with a highly sustained, multi-hour release of amino acids. This unique dual-release mechanism makes milk an incredibly popular post-workout recovery drink among professional athletes and fitness enthusiasts alike. While you rest, your muscles continuously draw on this steady stream of amino acids, repairing microtears and building new resilient muscle tissue. However, this process also triggers a powerful hormonal signal that is rarely discussed: the release of insulin-like growth factor 1, or IGF-1. IGF-1 is a highly potent anabolic hormone. Its primary role is to promote rapid cell growth, tissue regeneration, and muscle protein synthesis. During periods of rapid childhood growth or intense physical training, this anabolic signal is highly beneficial, helping the body adapt and build structure. But in excess, or under certain metabolic conditions, elevated IGF-1 levels can trigger unwanted side effects across various tissues in your body. For instance, high levels of IGF-1 can overstimulate the skin's sebaceous glands, causing them to produce excessive amounts of oil, known as sebum. This excess sebum can easily clog pores, leading to increased inflammation and worsening acne breakouts in individuals who are genetically predisposed. Furthermore, ongoing clinical research is investigating whether extremely high dairy consumption might be linked to certain hormone-sensitive cancers. While the current scientific evidence is not entirely conclusive, it remains an active area of study that warrants careful attention and moderate consumption. The key takeaway is not to panic, but to recognize that milk is not a neutral beverage. It is a powerful biological fluid with real hormonal consequences. Now, let us look at what happens when you drink milk every single day for several weeks. If your body tolerates lactose well, the long-term benefits begin to compound. Your bone mineral density can steadily improve, especially if you are young, pregnant, or experiencing a stage of elevated metabolic and structural demand. Additionally, the unique combination of calcium, potassium, and magnesium in milk works synergistically to help regulate and maintain healthy blood pressure. In a healthy gut, lactose can even act as a mild prebiotic, feeding and nourishing beneficial bacterial strains within your complex microbiome. However, if you suffer from pre-existing gut conditions, like irritable bowel syndrome, the casein protein in milk can act as a persistent, silent irritant. The A1 beta-casein variant found in most commercial cow's milk releases a specific peptide during digestion that can trigger low-grade, chronic gut inflammation. Another silent issue is the risk of an unintentional caloric surplus. A single glass of whole milk contains roughly 150 calories. Drinking 2 glasses a day adds an extra 300 calories to your diet. Without physical activity to offset this, your body will store it as fat over time. To determine if milk is truly working for your unique body, we recommend paying close attention to 3 specific biological indicators. First, monitor your digestion. If you experience persistent bloating, gas, or stomach discomfort after consuming dairy, your gut is sending a clear warning. Second, watch your skin. If you are prone to acne, try eliminating all dairy for 3 full weeks. If your skin clears, you have your direct biological answer. Third, track your daily energy and weight. If milk helps you stay full and your weight remains stable, your body is likely incorporating the nutrients efficiently. If you choose to keep dairy, select fermented options like kefir or Greek yogurt, which are rich in beneficial probiotics and contain significantly less lactose. Ultimately, there is no single diet that fits everyone. Listen to your body's subtle feedback, analyze the raw science, and make the choice that supports your unique biology.